This is Professor Derek Seitz. Normal curve. This video shows some concepts about the normal curve using Microsoft Excel. You see here a graph of what's called the normal curve. And over here is the function formula for this function. In the left, here are x values, 100 of them. If we scroll down, there's 100 of these x values, and then function values at each of those x values. There's two values that you must enter into the blue cells here: the mean of the normal distribution and the standard deviation of the normal distribution. And for this case here, I'm starting with the standard normal distribution, which has a mean of 0 and a standard deviation of 1, as indicated by the comments there. This data delta takes 8 times the standard deviation and divides it by 100 to get a range of 4 standard deviations on either side of the mean, and that's where the graph is going to be drawn. We start here with the first x value being 4 standard deviations to the left of the mean. The value is calculated using Microsoft Excel's normal distribution function with a last parameter of false, so that you get this probability distribution function curve, rather than calculating cumulative probabilities. And these are replicated down. You don't need to change any of these values. That's to draw the graph. The normal function is quite amazing. If we look at it here, notice that it has the mean in it, mu, and the standard deviation has to have those. And it also has pi, which is a famous irrational number, and little e, another famous irrational number. It's one of these amazing functions, and its graph looks like that. Some properties of this graph that are very interesting are listed over here. It's symmetrical around the mean, a vertical axis through the mean, and it's bell-shaped. Its maximum point occurs at the mean, which in this case is at 0. It has inflection points at plus and minus sigma. So in this case at 1 right here is what's called an inflection point, where the curve is curving downward, and now it's going to change right at that point to curving upward. Similarly over here it's curving upward, and when it gets to this -1 it starts curving downwards. Those are called inflection points. The total area under the curve is exactly equal to 1. However, amazingly, these tails go infinitely far in either direction, get closer and closer to the x-axis, but never touch it. And in the limit, the area, the total area, is 1. Also, the most important feature of all about this function, this curve, is that the area over any interval underneath the curve is equal to the probability of an outcome from an experiment that is distributed according to this distribution of occurring within that interval. So this is a probability curve where we can obtain probabilities of things happening that are in the context of this kind of a distribution. If we change the mean, we'll change the mean to be 50 and the standard deviation to be 10. It recalculates everything. Notice now it recalculated all these ordered pairs to be 4 standard deviations out on either side of the mean. The mean is now 50 and the standard deviation is 10. So there's 1, 2, 3, 4 standard deviations. So very powerful. They have this capability to instantly look at the change here for a different mean and standard deviation, and to understand the concepts for this very important probability function called the normal curve.